Okay, is the screen visible? Can someone confirm? Hello.
Yes, sir.
Okay. Okay. So hello everyone. Uh, Today we'll solve some problems regarding week 2 of quantum mechanics and molecular spectroscopy. So so we'll um, start from simple problems. Like here is the first problem. Um, and let me tell you, if you have any doubts regarding the second week of the class, you can ask me. We can discuss about your doubts, and related to any question also you can ask me. Okay. Okay, let's start now. Okay, so the first problem is consider a particle in one dimensional box. It is in ground state, that means n is 1. Then calculate the probability of finding the particle in the region 0 to L by 3. Okay, this is the first question. Then consider the mass of the particle is m. Then what is the expected energy of the particle in this region? Okay, so we are given a 1D box. Okay, so let's assume this is a 1D box. Our particle is trapped in this box. Okay, so and n is 1. So you know, particles in quantum mechanics, they behave like both particles and waves. So they have wave function also. Means they behave like waves, so they are associated with some wave function. Okay, so what are the possibilities of the wave function inside this one dimensional box? So if the particle is described by this wave function psi, then it will have some wave nature, right? So how many ways can we describe the particle inside this box? Like a wave, that means it will have some wavelength, right? So it will have some starting node and end node, right? These are nodes. These points are nodes. So let's say this is a 1D box of length L. Then what will be the ground state of this particle in this box? Let's say this is an endpoint, this is an endpoint. So this can be sorry for the bad drawing. So this can be a acceptable solution for this wave, right? Because let's take an analogy with rope, right? If you fix the rope in one end, and if you try to oscillate the other end of the rope, then what kind of shape will you observe? If you fix the one end of the rope and you hold the other end of the rope and you will try to oscillate it, so what kind of oscillation you will watch? First, you will watch this kind of oscillation. This will go like this, then it will come like this, right? Or you can watch some oscillation pattern like this, or some oscillation pattern like this, right? Just observe it. That means these all are the possible modes of this wave for the rope, for this rope. Similarly, particle remaining residing in this one dimensional box, that means the particle can't escape and it has to lie, it has to feel this one dimensional rope. That means you can imagine an ant walking on a rope. For him or for it, uh, what are the possibilities? It can go forward or backward. It can't go up and down, right? It has to move on the rope. So the particle inside a 1D box, it will feel like ant, and it has to move inside this or on this rope, right? Or you can imagine an electron moving inside a wire. It also feels potential like one dimensional box, because a wire is a one dimensional structure, and if an electron inside there inside, it has to move inside this wire. Okay, so what are the possible modes a particle can have inside this one dimensional potential? Either it can have this, or this. Okay, so what what is the minimum node it can exhibit? So this one. So we can say this is n equal to 1, n equal to 2, n equal to 3, n equal to 4, and so on. Okay, so we are given n equal to 1. So I assume you already studied about this one dimensional particle. So I am just writing the wave function corresponding to this system. So the wave function, the general wave function for a particle inside this one dimensional box will be 2 pi L sine n pi x by L, right? Where this L is the length of the one dimensional box. Okay, and n are the modes or states of the particles inside this one dimensional box. So we are asked what is the probability that the particle will be found between 0 to L by 3. So how to calculate probability? Just let me ask you one question. From 0 to L, what will be the value of this? Can anyone tell me? Any guess? L is the length of the box, let's say 0 to L, and I am squaring the wave function, and I am integrating from 0 to L. What will be the value of this? Okay, so it will be 1, because why it has to be 1? Because our wave function need to be normalized to preserve probability, right? So this quantity is the condition of normalization. Means if it is not normalized, let's say some arbitrary values more than 1, let's say 5, then when you calculate the probability, it will give values more than 1. Means let's say it will give some value 1.2. that means what, 120%. The probability of 120% does not make any sense, right? So our wave function has to be normalized, right? So it imposes a condition that this psi square should be 1. Okay, now we are asked, or this you can say that total probability. Okay, if it is summation over I, or integration is the summation ultimately, so summation of probabilities should be 1. Okay, so we are asked what is the probability that particle is residing between 0 to L by 3. Okay, so what we have to do, we have to integrate this wave function between 0 to L by 3. Okay, so what will be the value of this? I have given you psi of x. You have to do the mod square and integrate it. I am giving you 5 minutes. Just try it and tell me the answer. You have to just do square of this wave function and integrate. I'll wait for 5 minutes, or no, 5 minutes will be more. Let's say 3 minutes. Take 3 minutes, then tell me the answer. You have to just square this and integrate from 0 to L by 3. Okay. Okay, so 3 minutes done. Anybody? Okay, let's do this. So we have to calculate this quantity 0 to. You can interrupt me if you get the answer before me. Okay, so I am doing this. Of course, px. So squaring this, that means 2 by L, 0 to L by 3, then sine square and pi x by L. Okay, so we can't do integration directly to sine square, so we have to convert it to linear form. So let's say cos 2x, we can express it as 1 minus 2 sine square x. Okay, so from this we can find sine square x equal to 1 minus cos 2x by 2. I assume you guys are from BSc level, so I am doing this every steps. So we can substitute this here. We will substitute this 1 minus cos 2n pi x over L by 2. Okay, so 2 we can take outside, it will cancel, 1 over L. Okay, so integration of dx 0 to L by 3 minus 1 over L integration of cos 2 n pi x L 0 to L by 3. So far no one got answer. Okay, 1 by L, and then this is L 0 to L by 3, 1 by L. What is the integration of cos theta? Hello? Yeah. Sin theta or minus sin theta? Sin theta. Okay. You can speak, right? I can't read. I'm writing. So sin 2n pi x by L by this constant, whatever the constant is, 2n pi over L. Integrating limit is 0 to L by 3. Okay, so putting the limits, we'll have 1 over L, then L by 3. If you put lower limit, it will be 0. So this is 1 by 3 minus 1 over L. This is L by 2n pi. Then we have to put the limit. So let's put the first limit, sine of 2n pi by L. First limit is L by 3 minus, putting 0 here, it will be sine of 0 is 0. Okay, so we have to solve this. 1 by 3 and LL also cancels here. 1 by 2n pi sine of 2n pi by 3, and we are given n is equal to 1. That means it's in ground state, so this is 1 by 3 minus 1 by 2 pi sine 2 pi over 3. What is the value of sine 2 pi over 3? Sine 2 pi over 3 is how much in degree? 2 pi over 3 is how much in degree? Is it half? Sine 2 pi over 3 is how much in degree? Pi is how much in degree? Pi is okay. Pi is 180 degrees in degrees, and this is in radian form, this is in degree. Okay, so this is 2 pi means 360 by 3, so this is sine 360 by 3, that means sine 120 degree. How much sine 120 degree? Anyone? You can check in Google if you don't remember it. Okay. So sin 120 is root 3 by 2. Correct me if I am wrong. So let's put this value. It will be 1 by 3 minus 1 by 2 pi. This is root 3 over 2. Okay. So it's 1 by 3 root 3 over 4 pi. You can further solve this or put this in calculator. This is the final answer. This is the answer for the first question. Calculate the probability of finding the particle in the region 0 to L by 3. If I am being asked find the probability between 0 to L by 2, then you have to do integration 0 to L by 2. Okay. And do the psi square. You have to take the mod square, and then this integration will give the probability. Okay. This is the probability formula. Okay, let's come to the next question. Consider that particle has some mass m. Then what is the expected energy of the particle in this region? Okay. Do you know how to calculate expectation value? Like, let me ask you, what is the expectation value of x if we are given psi? This is y function you are given, and you have to find the most likely position inside this box 0 to 12 where the particle can be found most of the time. You are given psi. Anyone? Okay. So expectation value of any parameter, let's say a, given a wave function will be psi star a psi. Integration depends on x, it will be x. Okay, and limit, whatever the limit means boundary of that question. For this case it will be 0 to L. Okay, so we are asked okay, so so the most expected value of position according to this will be psi star x into x I x dx 0 to L. But we are not asked this position, we are asked energy, expected energy in this region means 0 to L by 3. Okay, so energy expectation. What is the operator for energy expectation? What is the operator for energy? Like for momentum we have minus I h. Yes. Hello.
Sir, H prime.
No.
H.
Yes.
Yes,
Hamiltonian.
Hamiltonian.
The operator for energy is Hamiltonian. Okay, so in this case our wave function depends on x, right? So Hamiltonian operator is proportional to this time derivative, right? Or it has another form, and this is h cross over h cross del square by del x square plus g of x. Do you recognize this? This is the Hamiltonian operator. If you apply on any wave function psi, then it becomes Schrodinger equation, right? This is the time independent Schrodinger equation. So as our wave function depends on position only, so we will use this operator. Okay, so expectation of energy, this will be psi star h psi dx from 0 to L by 3. Okay, so we will apply this operator. So psi is given 2 by root 2 by L sine n pi x over L, right? So psi star will be complex conjugate of this, but it is already real, so psi star will be psi, right? Okay, we have to evaluate this h cap over psi. Let's do this first. So this okay, this is minus actually, because this is p square over 2m, right? So it will be 2m also. So this is minus h square by 2m del square over del x square. This wave function is 2l sine of n pi x over l. So you have to do derivative twice. So this is minus h square over 2m, and this is constant 2 over l square root, and we have to do derivative twice. Derivative of sine is cos, then again derivative of cos is okay, minus sign, right? So it will be minus, but the constants are there. I assume you all know derivative, so I am doing skipping the steps. Square, and this is n pi x by l, right? If I operate this h on psi, and this much I will get. Okay, so these all are constants, so I can take them out. So there is a minus here, there is a minus here, it will be plus. So effectively I will have h square by 2m. If you have any doubt, just interrupt me. Okay, n pi over l square, then this from this psi star we will have some root 2 by l, and from this I have already taken this out. Okay, so it's effectively sine square n pi x by l. Okay, from 0 to l by 3, and integration is with respect to dx, right? So it's h square over 2m, 2 by l, I am taking this outside, n pi by l square. Then this integration we already did here. See, we already got the answer, this much, with same limit also. Okay, 2 by l was there, so effectively we have to okay, 2 by l we have taken out. So with 2 by l, this will be 1 by 3 minus root 3 by 4 pi. Okay, did I make some mistake?
Sir, is the value of psi means root 2 by L sine n pi x by L is given, or it's a standard value?
This is
This is
this
This
root 2
this
by
root
L.
2 by L.
You will get by
You will
after
get by after
normalizing this wave
normalizing
function.
this wave function.
You
okay.
just
You just
This-
assume a
assume a
sign.
sign.
Can you mute?
Can you mute?
I'm getting double.
I'm getting double.
Okay, you can just take a sin b some x, then or b you already know n pi x over l. When you try to normalize this wave function, you will get the value of a as root 2 by l. Just try it. What do you have to do to normalize this wave function? The same condition, psi of x integrating from all the limits, it should be 1, right? So from here you will get some mod of a square. This value if you get, you have to just divide it, then you will get a square is 1 over this integration value, then you will do this root over, then you will get this a value, you will get it 2 by l. Okay. Okay, so any doubts so far? uh, I think I did right. Okay, so any doubts? Okay, then let's move on to the next question. Okay, consider a quantum harmonic oscillator with spring constant k and mass m. Then what is the energy level of the system? Okay, I assume you already have some knowledge about quantum mechanics, so just you know the answer. Just give me the answer. It's pretty standard quantum harmonic oscillator.
N plus half h cross
Yeah,
omega.
this is the right answer. The energy is n plus half h cross omega. So the minimum energy this system can have is half h cross omega. This can't have zero energy. This is the result of this this framework. The particle can't have zero energy. It has to have some minimum energy, which is quantized by this Planck's constant. Okay, so this is the answer. Okay, let's move to the next question. Okay, consider a particle in 1D box of length L and it's in ground state. Calculate the expectation value of position and momentum. Okay, I already explained you how to calculate the expectation value. So you have to calculate expectation value of x and expectation value of px. Let's assume it's in x direction, this 1D box 0 to L. So you have to calculate x, and how do you calculate? Can you tell me what I have to write? This is psi star. What I have to write?
F operator.
X
X.
psi. Yeah, of course this psi is function of x dx, and the integration limit
0 to L.
yeah.
0 to L.
Yeah.
Okay, can someone do fast integration and tell me the answer? This is only x, so it's, and psi you know, it's 2 by L sine n phi x over L. I am giving you psi. You just have to calculate this integration. Let's take 5 minutes because it will be some bigger integration, and tell me the answer. You just try, otherwise I'll do. In the last question, I did some mistake. There was some additional term, right? D of x, potential term. From this also it will contribute to energy, right? So if we assume it's a function of x, then we have to take its form. So for now, let's assume it's a constant. Then its integration will be 0 to L by 3. V you can take out, and this is mod psi square dx. Okay, so it will come some p, some value, and this integration psi square, this one. Over 3 minus 3 4 5. Okay, so I made some mistake last time. Okay, so 5 minutes are over. So anybody got some answer? Okay, I hope you all are trying. So let me do this. In the meanwhile, if you get answer, just interrupt me. Okay, so this is x, mod of psi square is 2 by L, this is sine square and pi x over L dx, and integration limit is 0 to L. So 2 by L will go out, and we have to do integration by parts because there are two functions now. I hope you all know the integration by parts. So I am taking this as u, this as v, but still it's very complicated function, sine square. So let me convert sine square of x as 1 minus cos 2x, or sine square theta is 1 minus cos 2 theta by 2. Okay, so let's substitute this. 2 by L x 1 minus cos 2 n pi x over L by 2. By 2 I can take outside, it's 0 to L. Okay, it's 2 to get cancelled. So it's pretty simple now. You have to just do one integration by parts. This is x dx 0 to L minus x cos 2 n pi x over L dx to L. Now this integration you have to do. This is pretty simple. So this is x square over 2 0 to L. Now this you have to do. Let's say this is u, this is v, then this is integration of u v, some function, let's say dx, then this is u integration of v minus derivative of u with some function, let's say x, integration of with respect to v dx. Okay, so then this will be x integration of this cos 2 theta, integration of cos is sine, so this is sine 2 n pi x over L. So the constants, the coefficients, so this one, this will be divided. I hope you all know this is standard integration. This is 0 to L, then minus this part. Okay, so I have to say this. Actually we have 1 by L also outside, so 1 by L here, 1 by L here, then minus derivative of x is 1, then integration of this is already there, sine 2 n pi x over L, and this constant L over 2 n pi dx 0 to L. Okay, so this part is 1 over L square over 2, this part I am writing. Okay, then minus 1 over L, you have to put limit. Okay, this is L over 2 n pi, this is L sine, if I put L, this is 2 n pi. No matter what I put n value, it will always be 0 or pi, right? 0 pi or 2 pi. For that, sine value is 0, and if I put 0 at x position, it also 0, right? So this whole function is 0. Then minus integration of this one, 1 over L is there, then L over 2 n pi, then integration of sine is minus cos, so this is, actually we take off this cover, so it's plus now, cos. Are you getting anything? I'm just solving 12.
Yes, sir. Yes.
Okay,
Okay.
and I have to divide the coefficient also, 2 and pi over L. Okay, so this L square, L cancels, L cancels, this all is 0, so no, don't bother about it. This is L cancels, this is L by 2 plus 1 over 2 n pi, and L over 2 n pi, and then there is a minus here. Let's, okay, then we can do one thing, put the lower limit first. So this will be cos 0, cos 0 is 1, minus upper limit is 2 n pi, now cos 2 n pi. Okay, so n value is 1, 2, 3, whatever you put, it will be some integer multiplication of cos 2 pi. What is the value of cos 2 pi?
1.
Yes, so this is 1 minus 1, so this also goes to 0, so ultimately we have L over 2, right? So what was, we are calculating the expectation value of x. So what is the meaning of this expectation value of x? We are getting L by 2 when we are searching in the one dimensional box whose length is L. What is the meaning of this expectation value is L over 2?
Sir, probability of getting the particle in the middle point.
Yes, right.
Yes, right.
That means what? Quantum mechanics is probabilistic. Probability. Sorry, my tongue is twisted. Quantum world is probabilistic. So when you do the experiment, let's say some 100 times you do the experiments, then most of the time what you will find, if you try to measure the position of that particle inside this box, so most of the time what you will find, you will find the particle is sitting in the middle of this box, right? So this distribution is like well like curve actually. That means if you say this is the distribution of probability, so you see most of the time you will find the particle in the middle, right? If you are searching in some region from here to here, in statistical mechanics we say this as 1 sigma region. That means 68% of the time you will find the particle in this region. I don't have the number exactly, what is the that you have to calculate. So 68% of the time, if you do the experiment 100 times to calculate the position of the particle, then 68 times you find the particle in this region, in this 1 sigma region, right? And most of the time you will find the particle in the middle of this box. Okay, so this is the expectation value of position. Now we are also asked what is the expectation value of momentum. Okay, so you have to calculate this. Do you know the operator for this px? What is the operator form of px in position space? It has some derivative form. Px is minus I h cross del over del x, right? This is the operator in quantum mechanics, right? So you have to calculate the expectation value of px. So what do we have to do? We have to calculate this integration psi star p px psi x dx from 0 to L. So you have to just calculate psi star minus I h cross del over del x, which will operate on this psi x ax 0 to L. Okay, so it's pretty simple. You have to just do one derivative, and the integration after that will be very simple. Let's take 5 minutes from now and tell me the answer. You have to put this psi value, this one, and you have to do some one derivative simply. Then you have to multiply this resultant with psi star, then one simple integration. Let's take 5 minutes and try. Okay, so time is over. Anybody got the answer? Okay, okay, you try. I'll also do. So you have to do one derivative and one integration, right? You have psi of x. So let's do this here. No, we don't have space there. So p of x expectation is psi star minus I h cross del over del x. Then this psi x is 2 pi l sin n pi x over l, right? So integration 0 to l dx. You have to do the derivative. This is let's this value also 2 by l and n pi x over l. So this will be minus I h cross 2 by l, then sin of n pi x over l. Derivative of sin is cos n pi x over l times the coefficient n pi over l dx 0 to l. Okay, so this is constant, I can take it out. So this will be minus I h cross 2 by l n pi over l. This is sin x into cos x. We can simply convert it to sin 2x actually. Sin 2 n pi x over l by 2 go to l. Then integration of sine is pretty simple, right? 2 to get cancels. This is minus I h cross n pi over l square. Integration of sine is minus cos, right? Then this is minus cos 2 n pi x over l by 2 n pi by l. Limit is 0 to l. Okay, so if I put the upper limit l, what will happen? I will get cos 2 n pi. Okay, so cos 2 n pi is 1, right? If whatever the value of n, it does not matter, it will always come as integer of 2 pi. So cos 2 pi effectively. So it is 1. Then if I put 0 also, then it will be 1, right? Minus 1 if you can take out. So it will be effectively 1 minus 1. So value will be 0. So what is the expectation value of x? 0. That means when you try to calculate its momentum of that particle inside this box, most of the time you will find it to be 0 inside this box. You will be finding it like not moving, but there will be some uncertainty in position also. But when you try to measure its momentum or velocity, let's say, then you will find it to be still. Okay, that's the meaning of this. Anybody have any question? Any doubts so far? It's simple. We have to just find the expectation. Expectation value means what is the most probable value of finding that observable, right? So if you try to calculate the expectation value of x, you will find L over 2. That means you will find the particle in the middle of the box most of the time, and if you try to compute its momentum, that means expectation value, you will find 0. That means most of the time you will find it's not moving, its velocity or momentum is 0, right? So let's move to the next question. Okay, so a particle in a quantum state described by the wave function, this one, and where this a is the normalization constant. Okay, then calculate the expected value of its energy. So it's a similar case. So it's a similar case. You have to find expectation value of energy, right? So what you have to operate on the operator, corresponding operator is minus h square over 2m del square over del x square plus b. Let's say it's constant. Okay, you operate this Hamiltonian and you do this integration psi star h cap psi dx. Here wave function is cos now. Don't bother about this constant. Keep it as it is. You have to do simply 2-time derivative and 1-time integration, right? And just take similar, right? Let's take 3 minutes now. You can do it. You have to do 2 times derivative of this cos. You will effectively get cos. Then you have to do integration once. Let's take 3 minutes. Just try. If you are not getting, that's okay.
So here psi star and psi will have same value, no? A cos k.
Yes,
Yes, because the
real, right?
real, right?
Real.
Yeah.
Yeah.
Okay, so let's do this. We have to do derivative twice of cos function, right? So doing 1-time derivative is minus of k sin kx, then second time derivative will give you minus k square cos kx, right? This is the second time derivative. So what you will have in this psi is a cos kx, right? So you will have a square then cos kx. So then we will have minus k square cos kx, and from this, okay, there is a constant here, minus h square over 2m, right? Then you will have this part also. I'm assuming this as a constant, so I'll take it outside. So b a square, and then this is sorry, psi is with a, right? So it's plus a square b, this is cos square kx dx, and so it's no limits are given, so we have to do indefinite integral. Okay, so let's say these are same integration actually, so we can take constants out, a square minus minus plus k square h square over 2m, and we'll have cos square kx. From here also k square kx, so let's say take the constants out, then we have to do integration 1 cos square kx dx, right? These are the constants, I am taking it out, and I have to do this integration. So this is a quadratic function. Doing integration of a quadratic function is pretty hard, so we have to convert it to linear form. So how do I convert this? Cos square kx okay, we have this relation cos 2 theta is equal to 2 cos square theta minus 1, right? So from where we can get cos square theta is equal to 1 plus cos 2 theta over 2. Now it's pretty simple. You have to do integration of the constant and cos 2 theta. So this will be 1/2. This integration I am just writing 1/2 x plus integration of cos x is sin x. So I'm taking this plus sin 2kx over 2k. So this is the answer, this constant, and this is the integration value, right? If you are given any limits, then you put the limit, otherwise this is the final answer. So the answer is a square k square h cross square over 2m plus a square b whole into half x plus sin 2kx over 2k, right? So this is the expectation value of energy. It's simple. You have to just do 2 derivatives, then 1 integration of this simple function cos, right? Any doubts so far? It's just derivative and integration, nothing else we are doing so far. So moving on to the next question. Okay, given two state system with unperturbed Hamiltonian as H0, which is this one, and time dependent perturbation as Vt, right? Then calculate the transition probability from initial state 1 to final state 2 at time t using time dependent perturbation theory, and assume v of t is b0 cos omega t, and where this b0 and omega are constants. So what is given, our unperturbed Hamiltonian is given, this one, and we are given two states, state 1 and state 2. So the energy of state 1 is this E1, and energy of state 2 is E2, right? Now we are given a perturbation, we are giving a perturbation to this system, which is this V of t, and V of t is V0 cos omega t, right? So this perturbation is clearly time dependent, and it varies as a function of cos. Now we have to find the transition probability from state 1 to 2, right? So from class you might be remembering the transition probability is equal to coefficient square. This is the time dependent coefficient of final state, which will be have the form 1 over h square integration of 0 to t, and initially it was in state 1 at time equal to 0, and at time equal to t we are searching it in second state. So what we can expect from this time evolved state, it will have some projection on this state 2, right? Otherwise the inner product will be 0, that means probability will be 0. So the evolved state, it have to have some projection on this state 2, right? So this integration will give e to the minus I omega fi t, and this inner product final state perturbed Hamiltonian initial state t, and its mod square, right? So it's looking very pretty complicated equation, and in next class probably you will learn some simple rule like Fermi golden rule. So according to Fermi golden rule, the transitional probability will have some form, like if some perturbation h prime is given, then the transition probability one second. This transition probability from state 1 to 2 will have the form 2 pi over h mod of this perturbed expectation value, and it's not actually expectation, let's say final initial what you call measurement of this value, or the projection of this evolved state. Let's say this is some evolved state phi onto this final state phi f, and this is f, so it's prime. So this quantity you call whatever it's, let's say you call this b of t. So this is b of t, mod times the Dirac delta function, which will be E2 minus E1 plus H1 some. Okay, can anyone tell me what does this Dirac delta function look like? Let's say this is x1 minus or x x minus a. How does this function looks like? Anyone?
So it will be a peak at only A.
Right. If this is x-axis and this is a, then this function will look like this. At a it will peak, and every other point it is 0. So this value is 1 when x equal to a, and this is 0 when x is not equal to a. Right. So what does this Dirac delta function implies here? What does this mean? Just doing a important thing here. Can anyone tell me? Let's assume this quantity is x and this quantity is a. So it will survive when x equal to a, right? This function delta e2 minus e1, let's say it's let's take stick to one value, h cross omega to 1. Okay, this is x, this is a. So this function will survive when x equal to a, right? That means e2 minus e1 have to be h cross omega to 1, right? When this condition satisfies, this function will survive, right? Then when this condition is satisfied, this will be equal to 1. What does this mean? There are two states, 1 and 2, and it has energy E1 and E2. So what does this condition means? That when you give like this is a angular frequency, let's say your some particle is here, you have to give some energy to this particle to shift this particle to this state, right? So you have to give some energy to this particle. How much energy you have to give to shift this particle to this second state? Exactly. Okay, right. This is E1. Exactly the difference between the energy, right? Like energy difference is E2 minus E1. This much energy is needed for this particle to shift from this state to this state, right? So this is the, let's say you are shining a photon on this particle so that it's gaining energy, this E2 minus E1, so that it's jumping to the state 2, right? So what is the energy, what should be the energy of this photon? H cross omega 2 1, which should be equal to the energy difference between the states, right? This delta function means conservation of energy actually. That means the energy of this perturbation should be exactly equal to the energy difference between the two states, right? Otherwise if it is less than this, let's say this condition does not hold, E2 minus E1 is greater than h cross omega, let's say this this you can assume this h cross h nu or something like this. Let's say energy of photon. So if E2 minus E1 is greater than this h cross omega, what will happen? If E2 minus E1 is greater than this h cross omega, that means the energy difference between these two states is higher than the energy provided to this particle. This means if you assume this is the energy of photon and I am shining some light on this particle, that means this photon is absorbed by this particle, this h cross omega, but it's not sufficient actually, because this E2 minus E1, the energy difference is pretty high than this energy supplied to this particle, so it won't jump, it will stay like this. So you have to give exactly h cross omega equal to E2 minus E1 energy to make the particle to jump from here to here. So this Dirac delta function signifies the conservation of energy, right? So according to Fermi golden rule, we have to just put the perturbation value here and take its mod square. So the transition probability will be 2 pi over h cross, what is the function, v naught is constant, you can take it out, v naught square, and mod of cos this omega t is E2 minus E1 of t. Let me write down here, p of 1 to 2 is just 2 pi over h cross v0 square cos this omega. Now that's 2 1 I have wrote, let's say this omega is, it has to be, h cross omega have to be E2 minus E1, right? So omega is E2 minus E1 by h cross. So this is E2 minus E1 by h cross t mod square, right? This is the probability of transition from state 1 to state 2. Any doubts? So this is the Fermi golden rule I have applied simply. Actually it's not taught in second week, maybe in third week it is being taught. So any doubts so far?
Yes.
Okay, if you have any doubts just interrupt me. Okay. Okay, so it's on next question. What is the energy expectation value of an electron in 2s state of an hydrogen atom? It's pretty easy. If you have done quantum mechanics first, you will be able to solve it pretty easily. So you guys want to try? Let's take 2 minutes. It's actually not 2 minutes job, it's pretty quick, but let's take 2 minutes and give me the answer. Okay, any answers? What is the ground state energy of hydrogen atom?
13.6 minus 13.6.
Minus 13.6. That means in 1s state, the electron which is uh, revolving around this proton, it will have energy minus 13.6. So do you know any general formula if it is in some other orbital? What is the quantum number of this ground state? N equal to
1.
yes. Okay, the next one N will be
2.
yeah. So the energy of any orbital for a hydrogen atom is minus 13.6, and there will be some function of energy. So sorry, the function of n. It should be function of n, right? I am writing it as En. So where this n will go? Minus 13.6. It will be multiplied with this or divided with this n.
Divided by n square.
Yes, it's not n, it's n square. So for this 2a state, n is 2, right? So the energy of this 2a state will be minus 13.6 divided by 4. What is this value?
3.4.
Yes, right. This is the answer. It's very, very simple question, right? So, okay, moving on to the next question. Okay, consider a spin-up particle in this state psi, which is a linear combination of this up state and down state in z direction. Then calculate the probability of measuring spin up and spin down in z direction. So this wave function is given, this 1 by root 2. It's very simple, you just can tell it by looking at this wave function. What will be the probability of spin up? The wave function is given. What will be the probability of spin up? This is some function is given, c1 phi1 c2 phi2, and this phi1 and phi2 are complete they form a complete set. That means what? You can express any wave function in terms of phi1 and phi2. So what will be the probability of finding p1?
0.5.
Okay, yeah. So this is mod of c1 square, right? So this is mod of 1 by root 2 square. So it is 1 by 2, right? It's 0.5. Then what is the probability of spin down?
Oh, 0.5.
Yeah, right. This is I over root 2 mod square. This is also half, 0.5. Or you can do one thing, 1 minus p spin off. It will also give you the same answer, right? So for a general wave function, the probability will be its coefficient square, right? So it's pretty easy. I hope you all understand this. Okay, moving on to the next question. Okay, now consider spin up particle is described by this wave function. Then calculate the expectation value of spin in x direction. It's pretty interesting now. So the wave function is given in terms of this complete set, it's root 3 spin up in z direction and spin down also in z direction, right? It forms a complete set. So we are asked what will be the probability of spin up in x direction, probability of spin down in x direction. We are given z direction, and we are given a basis in z direction. We have to find probability of finding that particle in spin up state in x direction and spin down state in x direction. So any guess how we will proceed? Do you know the spin operator?
No, sir.
Okay, then okay, I'll tell. So the spin operator in any direction, let's say x, so it's just h cross over 2 sigma of x, where this sigma, or let's say this is si, this is sigma I, where this sigma i's are these are the Pauli matrices. So do you know about Pauli matrices? It's 2 cross 2 matrices. There are 3 Pauli matrices: sigma x, sigma y, sigma z, right? And their trace is always trace is always 0, and they form a complete set actually. So we express the spin operator as in terms of this Pauli matrices. So for spin x, we will have h cross over 2 sigma x, right? So we are given the particles are in z direction, so the spin are in z direction, spin up and spin down. So it will be described by this operators sz, which will be h cross over h over 2 sigma z. So do you know the form of these Pauli matrices? These are 2 cross 2 matrices. Do anyone remember? What is the value of sigma z? Okay, I think you guys don't know. So okay, so it's 1 0 0 minus 1. You will find every time the trace of these matrices will be 0. So similarly sigma x will be 0 1 1 0, right? So these two are important for our case. So we have the spin operator in x direction as h cross over 2 0 1 1 0, and our particle are in z direction. So do you know the basis of this matrix 1 0 0 minus 1? Basis means eigenvector of this matrix. How can I form this matrix? Do you guys know how to calculate eigenvalues and eigenvectors?
Yes, sir.
Okay, so you just try to calculate its eigenvector. It's pretty simple. It's a 2 cross 2 matrix. You'll find this its eigenvector as 1 0 and 0 1, right? For now just take this as answer. So eigenvector of this sigma z are 1 0 and 0 1. So this up state I can write as 1 0 in matrix form, and down state I can write as 0 1. right? Now I have to measure its expectation value in x direction, right? So what I have to do, I have to operate this Sx onto this wave function psi, right? And psi of x we already wrote in matrix form, and s of x we already have matrix form. Then we have to just do the matrix multiplication. So let me ask you this. So if it is my ket vector is 1 0, what will be my bra vector? What will be the form of this?
It will be a row matrix.
Yes, it will be a row matrix 1 0. This is a column matrix, and then the 12 vector will be a row matrix, right? So okay, let's expand this psi s of x psi. So psi given as 1 by root 3 spin up plus root 2 by 3 spin down. Okay, so this we can write as k spin up bra vector 1 by root 3 plus spin down 2 by 3. Then we have to operate this on Sx. Sx have form h cross over 2 sigma x. Sigma x is 0 1 1 0, and this psi state is 1 over root 3 spin up 2 by 3 spin down. So we will have 4 terms, right? If you multiply these two, this if you expand it, you will have 4 terms. Up Sx up state, of course in z direction, down Sx down direction, then you will have mixed state, up Sx down down Sx up. So let's check one by one. So let's check this one. So up state is this is bra, right? So it will be row vector, so it is 1 0. Let's write the matrix only, constant we will ignore, we will write it later. So the matrix is 0 1 1 0. Then this ket vector will be 1 0 because it is up state. So you have to do matrix multiplication. What is the value of this? Quickly, 1 0, then this one 0 1, row column, right? So then this multiplication is 0. So this first term is giving 0. Let's check this one, 0 1 0 1 1 0 0 1. So this will be 0 1, then this 1 first row column, then second row column is 1 0. Then this multiplication also gives 0, right? All these two terms are giving 0. Now let's check this term. This is bra up, so 1 0, then this matrix 0 1 1 0, then ket down means 0 1, right? So it's 1 0, then this 1 column row into column, so it's 1 row into column this is 0. Now if you multiply this row into column, you will get 1. So we got some value non-zero here. For this it's 1. Now check this one. Down is 0 1. Then this matrix is 0 1 1 0. Up state is 1 0. Then this is 0 1. And this multiplication is row into column is 0. And the second one is 1. So it's 1. So we are also getting for this one as 1. So these two, when the states are same, we are getting expectation value 0. When the states are different, we are getting 1. So if we put this in this above equation, calculating the expectation value in spin up direction, in x direction, we are calculating the spin expectation in x direction. So we will get, so it's up will be 0, then up down it will be non-zero, so coefficient will be multiplied. So it's 1 by root 3 and here 2 by 3. So this cross term will survive, and this same spin state will go to 0. So similarly, this is down state and this is up state. This will survive. So this is root 2 by 3 from here and 1 by root 3 from here, right? And it will be multiplied with this constant h cross by 2. So effectively we have 2 root 2 by 3. Actually this is whole root 3. So this is the expectation value of Hx. Okay, it's h cross over 2 also. So it's h cross root 2 over 3. So it's pretty simple. Any doubts?
No, sir.
So we were given a state where this state is expressed in terms of spin up and spin down states in the z direction, but we were asked the expectation of this spin in x direction. So this is the procedure, and so we have to operate this spin operator onto these states. Then we got the expectation value of the spin operator in x direction is this much. Okay. Okay, then moving on to the next question. Consider the same you can do it. You have to calculate the probability of the particle being in this L by 4 to L by 2. What you have to do? You have to calculate this integration from L over 4 to L over 2. I think you all can do this same as previous questions. Just try, and you know the wave function. It's 1D box. So sine. So I am not doing it anymore. You guys try and find out the value. Okay. Coming to question number 10. Okay, for a quantum harmonic oscillator in n equal to 3 state, calculate the probability of finding the particle within the range minus a to a, where a is a positive constant. Okay, so I am assuming we guys already studied quantum harmonic oscillator. So I'll start from wave function. The wave function for quantum harmonic oscillator will have the form. Actually it is expressed in terms of this Hermite polynomial, and its wave function is written as number 2 to the power n factorial m omega over phi h cross another 4 to the power of minus n omega x square 2h cross square, sorry, h cross, and this Hermite polynomial. So this is a polynomial according to this n value it will have different form. I assume you already know this quantum harmonic oscillator. Do you guys know about quantum harmonic oscillator? So energy plus half h cross omega. I guess you already know, right?
Yes, sir.
Okay, so it's very lengthy process to calculate the wave function in this class, so I just wrote it. So you have wave function. So what you have to do? You have to calculate the probability of the particle finding from calculate the probability from minus a to a. So you have to calculate this term, right? So psi you have to do this integration. So this polynomial, let me tell you, h of 3 and n is 3, it will have, if it is a function of z, it will have 8z cube plus 2z. Okay, so z is m omega over h cross for you, so you just put it and do this integration. It's pretty simple, right? It's same procedure. Okay, moving on to the next question. Okay, it's very simple short question. What is the relation between electric field and scalar and vector potential? What is the relation? It's being taught in week 2 last class, I think. Phi is the scalar potential and A is the vector potential, right? So the formalism is electric field has 3 components, Ex, Ey and Ez. Similarly, the magnetic field also have 3 components, so total 6 parameters. And the dynamics of this electric field and magnetic field are described by Maxwell's equations. So how many equations we have? 4 Maxwell's equations. So 4 equations and 6 parameters. So actually it's not exactly 4. Means effectively we have 4. So each equation, let's say this divergence of E for free space is 0. This is itself 3 equations, and similarly all the other 3 equations also are each 3 equations for x, y and z. Okay, so it doesn't matter. So to simplify things, like we had 6 parameters previously, so to simplify things we move to another space, the potential space, where this phi is scalar potential and this A is vector potential, and this vector potential, it has 3 components, x, y, z, right? So effectively we have 4 parameters now. So if you go to if you study further quantum mechanics, you will find this formalism has some benefits. So if we change the parameters to this potential form, then we can write Maxwell equation, 4 equation into one simple equation, one compact form of Maxwell equation. So you will learn this later. So for now, the answer for this electric field is this one. The correct relation between the electric field with the scalar potential and vector potential is this one, minus of gradient of phi minus del A over del T. It's the time derivative of this vector potential combined with the curvature of this scalar potential will give you, or the space variation of phi will give you the electric field, right? That's vector, actually it's not an operator. So this is the right answer. So moving on to the next question, what is the relation between magnetic field and the potentials? So this is okay, one more question is there, last question. So what is the relation? It's simple, right? This is the curvature of vector potential will give you magnetic field. It's being taught in week 2. Both scalar and vector potential are contributing to this electric field, and only the vector potential is contributing to the magnetic field. Curvature of this, sorry, not curvature, this what we call, this cross product will give you the magnetic field. What is called this quantity?
Curl.
Curl, yeah, right. Curl of this vector potential will give you the magnetic field. So coming to the last question, what is the relation between the speed of the electromagnetic wave with the permittivity and permeability free space? Okay, it's these all are sorry, ignore this. Let me give you manually. 1 over mu 0 epsilon 0 so c square equal to 1 over mu 0 epsilon 0 c square equal to, so which one, this one or this, which one is the right relation? If you consider the electromagnetic wave as light, then the c is speed of light. How it relates to the permeability and permittivity of free space? Permittivity is epsilon naught of free space, permeability is mu naught. What is the relation?
The third option.
Which one?
Third option, c square is equal to 1 by under root mu.
No, this is the second question. Second option, c square. If it is c, then this is mu naught epsilon naught. You can check dimensionality. You put its units and its unit, you will check this is meter per second, and if you put their units, you check this condition is satisfied. So second one is the right answer. Okay, so I don't have more questions and it's time also. So do you guys have any questions or any doubts?
No, sir.
Okay, if you have any doubt regarding last week's class also, you can ask me. Related to this problem set also, you can ask me. If you find it later also, you can mail me. Okay, so now it's time. So see you guys in next class.
Thank you, sir.
Bye bye.